What are the differences between oil hybrid, plug-in hybrid, and range extender? What is their underlying technical logic? Should we consider hybrid models when buying a car? Today, I will explain it all in detail. First, the essence of hybrid technology is the efficient use of energy and optimization of the driving experience through the collaboration of a fuel engine and an electric motor. Simply put, people think fuel cars consume too much fuel, which is hard on the wallet, but electric cars have limited range, so a hybrid approach was devised. The earliest hybrid technology to appear was non-plug-in hybrid, also commonly referred to as oil hybrid. Its technical design logic does not rely on external charging, using the motor's power to compensate for the engine's shortcomings in inefficient scenarios, allowing the engine to work as much as possible only in the efficient range. Its core hardware includes an engine and a small battery, as well as a drive motor and a generator motor. First, let's talk about the advantages. In low-speed and idle scenarios in urban areas, the engine can be turned off, relying on the motor to drive the wheels, avoiding inefficient idling of the engine. Therefore, in low-speed traffic jams, fuel consumption is 30 to 50% lower than that of a pure gasoline car. At medium speeds, the engine, part of the power generated by the engine, will directly drive the wheels, while another part will generate electricity to be stored in the battery. During high-speed cruising, the engine power mainly drives the wheels, and the motor assists in adjusting the speed to keep the engine efficiently outputting. In cases of rapid acceleration, the engine will generate electricity and drive the motor, both outputting power to the wheels to enhance power response. At the same time, during braking, the system automatically cuts off engine power and switches to generator mode through the connected drive motor, storing electrical energy in the battery. Its drawbacks are also evident. Because the motor power is small and the battery capacity is low, it cannot output high power for a long time, so it cannot achieve the performance boost of using pure electric drive. Additionally, because its power combination is more complex compared to pure fuel vehicles, its price is also somewhat higher. Moreover, in most regions domestically, it is not recognized as a new energy vehicle, so it cannot enjoy new energy subsidies. However, it uses a smaller battery with a shallow charge and discharge mode, so battery maintenance and degradation are almost negligible. To further enhance vehicle performance and experience, plug-in hybrid or plug-in hybrid electric vehicle emerged later. Its core logic is to upgrade to a large capacity battery and external charging to achieve short-distance pure electric and long-distance hybrid scenarios. Through a large battery capacity, usually between 10 to 40 kilowatt-hours, it drives a larger motor power, which can both unleash the performance of an electric vehicle and start the engine for power output when the battery is low. The main difference between it and a hybrid is that a plug-in hybrid uses external active charging, allowing it to be driven directly by the motor, making its driving performance similar to that of a pure electric vehicle, but only for short distances, generally around 50 to 200 kilometers. When the battery is depleted and switches to engine power mode, the acceleration driving experience will also plummet. Because a large battery is built in, this increases the weight of the vehicle, making handling inferior to fuel models of the same class, and fuel consumption will also increase. Although its battery is smaller than that of a pure electric vehicle, it still requires frequent charging and discharging, and battery degradation is inevitable. If the battery degrades to below 50%, the replacement cost accounts for about 10 to 20% of the vehicle's price, far exceeding the cost of small batteries in hybrid models. Plug-in hybrids actually use a complex power coupling system to coordinate the work of the motor and the engine. It is precisely because of the complexity of this system that the probability of malfunction is higher than in other models. Most people seem to prefer the feel of pure electric driving, but want a longer range. So an extended range hybrid architecture was developed. Its core logic is to focus on pure electric drive, with the engine only serving as a range extender, allowing for the choice of the more thermally efficient Miller cycle or Atkinson cycle. Its thermal efficiency can reach 40%, and it only functions as a generator, not needing to drive the wheels. And its battery capacity is generally around 20 to 60 kilowatt-hours, supporting pure electric range of 50 to 300 kilometers, almost fully covering urban driving distances. When the battery is low, the engine starts to generate electricity to replenish it. Its driving experience, whether short or long distance, is closer to pure electric vehicles. Some say the range extender design architecture is the lowest technical threshold among hybrid models, which is undeniable, but this simple design, compared to the plug-in hybrid mode, also has a lower failure rate and maintenance cost. However, in long-distance high-speed or uphill high-load driving scenarios, if the engine power is insufficient due to the need for continuous high-power output, the power generation may not keep up with the power consumption, leading to a rapid decrease in battery charge and severe power attenuation. In the case of low battery, because the engine does not directly drive the wheels but instead converts energy to drive the vehicle, the energy conversion efficiency of this process is about 30 to 36%, while the efficiency of direct engine drive is about 35 to 40%. Clearly, this power conversion is relatively lower. The fuel economy directly decreases, making it more fuel consuming. Overall, in hybrid models, because the battery is smaller and the motor only serves as a Auxiliary and lightweight drive without external charging is undoubtedly a better choice for those who like fuel cars but want to save fuel and do not have convenient charging environments. As for plug-in hybrid and range-extended models, because they all use external charging and adopt fast charge and discharge modes, battery degradation is unavoidable. Additionally, since it is not a pure electric mode, there will be losses in power conversion. Because it has both a large battery and an engine, its body structure is generally larger, so it is often used in PHEV models. Due to the heavy load and complex structure, the cost and price are also higher.
Your subscribe gives us motivation, and if you'd like to support us even more, you can send a super thanks or join our channel membership. Even a small support from you helps us create better videos.